Hi, welcome to a lesson on triangles, congruence, and other theorems. So we're going to start by asking you what is filling your bucket today and what is draining it. So filling your bucket, that's like a positive thing. Like what is helping you manage today? I love to see the little flowers popping up in my garden. What is draining your bucket? What is making things difficult for you? And so please share. And sometimes acknowledging things help us move forward. All right, then we're going to go on to proving triangles are congruent. Now, recall that the definition of congruent means figures that are exactly the same size and same shape. Rigid transformations like reflections, rotations, and translations result in congruent figures. Now we're going to be talking about congruent triangles in this lesson. And there's a lot of different postulates, some people call them theorems, that will help us prove when triangles are congruent. And typically we want to look at three aspects of one triangle and compare them against three aspects of another triangle. And the simplest of all congruent triangle theorems is the side, side, side. That is, if three sides of one triangle are congruent to three sides of another triangle, then we can say these two triangles are congruent. In other words, if this orange side, AB, is congruent to side DE, the blue side BE has two tick marks. It's congruent to this side over here, EF, and side AC, which has the three tick marks, is congruent to side DF. So what I've done is I've written a triangle congruence statement. And so you're going to get used to writing these statements. You want to start off with a little triangle symbol, and then I just wrote ABC is congruent to triangle DEF. Now, believe it or not, the order matters of these letters. DEF is not just some random order. I started from A to B. I went along the side that had one mark, and then B to C along the side that had two marks. That's why the order is A, B, C. D to E is one mark. E to F is two marks. So that's some of the things that we're going to be doing, is using these congruence theorems. Now, one thing you need to know is when we talk about the word included in geometry has a different meaning than included, let's say, I don't know, with a group of friends. Included in geometry means in between. And so right here, angle A is included between side BA and AC. Angle A is included. Notice the way we make the angle symbol. Kind of like that. Not exactly a less than. Sometimes you'll see it this way. Okay. Side BC is included between angle B and angle C. So side BC is the included side. Now notice the little segment symbol on top. That tells you we're talking about a line segment. Very important to be precise in geometry. There's another congruence theorem that will be pretty easy to spot, and this is the side angle side, or SAS congruence postulate. When two sides of one triangle and the included angle, right, that's the included angle, are congruent to two sides of another triangle and the included angle, then we can say these two triangles are congruent. And we can see this in pictures, or maybe they'll give us a statement. In one triangle, side AB is congruent to side DE. Also, in the first triangle, angle A is congruent to angle D, and side AC is congruent to side DF. Then we know that these triangles are congruent by side, angle, side. Now, notice the way I've written this, and I'm going to grab my pen. I've written it by CAB. Now, order matters. Now, notice what we're doing. We're following the side that had the 2 marks, then the included angle, and then the side that had the 1 mark. So is congruent to triangle FDE. All right, there's going to be another congruence theorem that you're going to need to know, and it's the angle-side angle. When 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle. So notice it goes angle, side, angle. I like to kind of start here and just say what it is that's being noted. An angle, a side, and an angle is congruent to an angle, side, and an angle. Now we know these triangles are congruent, and the statement that we're going to write, I've done A, C, B, is congruent to triangle. Now notice A, and then the side that's included, and then the angle with 2 hatch marks. So is congruent to triangle D, F, yes, D, F, E. All right, moving on to angle, angle, side. There's going to be a lot of triangle congruence theorems. You really got to keep these straight, which is why it's important that you have access to this paired deck, and you can go back and look at it anytime you need to, okay? Angle, angle, side. So this says when 2 angles, like that are shown, and the non-included side of one triangle are congruent to 2 angles and the non-included side of the other triangle, then these triangles are congruent by angle, angle, side. And so let's write our statement here, our congruent statement. Triangle BAC. Notice I went the angle with the 2 loops, the 1 loop, and then the side is congruent to triangle, 2 loops, 1 loop, and side, EDF. All right, there is still another triangle congruence theorem, and this is the hypotenuse leg. And this is the one exception where we're really looking at what could be considered angle, side, side. When you think about it, you start at this angle and that angle, angle, side, side, but there is no angle, side, side congruence theorem. However, there is a hypotenuse leg, and that is in a right triangle, if the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of another triangle, then these triangles are congruent. And so now we're going to go ahead and write our statement. Triangle BAC. Notice I started at B. I traveled up the hypotenuse and I traveled down toward that right angle. So EDF. That's the hypotenuse leg. And there's just things I've been talking about. I've been talking about these tick marks, sometimes called hatch marks, sometimes just called marks. If there's 1 on this side and there's 1 on that side, it tells you that segment AD segment, so notice I need my little line segment marking, is congruent to segment DC. Now, another way to show that 2 sides are congruent is if you have a triangle like what's shown. It's a little bit hard to see. We have a triangle right here, which is DAB, and we have another triangle right next to it, which is DCB. And the bottom side, well, they're supposed to be the same base here. The triangles share this side. So in that case, we say that the side that it shares, DB, is congruent to itself. We're going to learn about this special property called the reflexive property. But for now, just know that anytime 2 triangles touch, the side they share can be counted as one of the ways that we're looking to see the triangles are congruent. Okay, you've got one thing that I want you to do right here. And I'm going to look at the directions with you, and I'm going to get you started, and then you're going to go ahead and see if you can do it. Match each pair of triangles that's listed over here, right? So there's 5 pairs of triangles. with the correct postulate to prove the triangles are congruent. I noticed in this bottom pair that there was a hypotenuse and a leg of this triangle that were congruent to a hypotenuse and a leg of this triangle. Therefore, with my line tool, I matched this pair with that postulate. Your job is to match all the rest.